Hello everyone, welcome back to another video on generic series. In today's session, we will discuss about generic constraints in Swift. We will understand what they are, where they are useful, and how they help us to write safe and more flexible code. And if you have not watched my previous videos on generics, I highly recommend checking them out first, as they will make this topic much easier to understand. So with that said, let's get started. In the previous videos, we learned how generic help us to write flexible and type safe code, but sometimes being too generic can become a problem. In this function, I want to compare two values and return a greater one, but here compiler gives us an error because here not have any guarantee that the every value support the greater operator here, not only greater, equal and less than, and another operator as well. So this is where the generic constraints come in the picture. So this is why the constraints are important when we are working with the generic code. So they let you restrict what type can be used with the generic function or the object. So this forces the generic type to be conformed to that specific rule, right? So without constraint, a generic placeholder can be absolutely anything. This limit you because the Swift cannot guarantee that the past type support the basic operation like addition, subtraction, comparison, or looping, etc. So to make this function work, let me add a constraint here. So here we want to compare two values. So here we need to add comparable protocol constraint. So to add a constraint, we need to just add the colon and with the any constraint which we want to add here. So this is a syntax to add the constraint. So now we can compare the value. So let me call the function. Okay, yes, so let me try the with string as well. Yes, the result here. So this is why the constraints are important in the generic. Basically, the generic constraints force the generic type to conform to that specific rules. So now, as all we know about the importance of the constraint in generic and how to implement the constraint. So now we will discuss about constraint types. So basically, the generic constraints are categorized into the two categories. First one is class constraint, and the second one is protocol constraint. First one we will discuss about class constraint. A class constraint limits a generic placeholders so that it can only be accept the class type rather than struct or enum. The most common reason to use any object as generic constraint is that when we need a feature which only support by the class instance, such as weak reference, so we need to use any object for that. As we know, the Swift struct and enums are value type, they not support the weak reference. So by adding any object as placeholder constraint, so we guarantee that the placeholder type will always be class type. To demonstrate the functionality of any object with the generic constraints, I have create this function. In this function, I have add the any object constraint to it, and here I've used the identity operator, which is basically used to identify whether the constant and the variables are passed to it are belongs to the same instance of the class in the memory. So let me run the code. Yes, here we got the result. Sometimes we want to mutate the value, as all we know the classes are the reference type. So for that we can use the class constraint. So let me create one function for that. As you can see, here we got the compiler error because the any object not have any parameter related to the any. Let me create one class u profile. Even we have set the any object, but we got the error because the any object don't know about the name of this. So to overcome this problem we need to use the specific subclass constraint. So to fix this problem we can use subclass constraint. Let me create one. So here we have operated this. So this is another type to use the class constraint. The first one is any object, the second one is subclass constraint, and we can also use the protocol constraint. So let me create the another function to demonstrate the protocol constraint. We can also use the protocol restricted with the class type to resolve the same problem. So let me create the protocol. But with the protocol approach, we need to initialize the value which are defined in protocol, as you can see in the both classes here and here with the initializer. So let me update the value. Yeah, here we got the result. So now let's come on the protocol constraints. So the protocol constraints are forces to the generic placeholder to conform only the specific protocols, unlike the class constraint, which basically restrict the generic type to follow the class tree, as we can see in the class constraint examples. So in the protocol constraint, basically protocol constraint focuses entirely on the behavior and the capabilities. So it tells the Swift compiler, I don't care about what type the object is, right? So as long as it is capable of performing those specific actions. So let me explain protocol constraints with the examples. So let me clean this code first. So as you can see in this example, I have a create one storable protocol with the ID parameter, and here I have create the repository conform with the storable constraint, a protocol constraint here, and with the items and with one receive function. And here I have a create two models with the storable protocol, conform with the storable protocol. And here in this function I have used those repositories. We are using protocol constraint every day in Swift without realizing it. Some built-in protocol constraints are equitable, hashable, comparable, etc. So at this point you might be wondering, when should we use protocol constraint over the class constraint? So to use protocol constraint when your type does not share a logical parent relation. For example, a user or a network request have absolutely nothing in common structurally, but they might both need to be capable for printing text. So instead of forcing them into the await class inheritance tree, so you should give them a loggable protocol, or constraint your login engine to a like loggable protocol constraint. Let's create examples. So as I have created these two functions, one with the comparable protocol constraint and another one is equitable protocol constraint. Sometimes a single constraint is not enough. We may need a type that support multiple constraints. Swift allow us to combine constraint using ampersand or where clause. So this means generic type must satisfy all the specific protocols. So in the following example, like in process function, I have used ampersand to combine identifiable or loggable protocols, right? So in the following examples, use the where clause, or use the where clause to combine multiple protocols here. So the thumb rule is that so use the where clause when constraint become complex. Thanks for watching. See you in the next video, and don't forget to subscribe for more informative content.